Okay, so I'm going to say just a word or two about shapes of distributions. If a distribution is symmetrical, the mean and the median are equal. The mean is like the balance point. If you picture this distribution curve as like a piece of metal, you know, kind of thick piece of steel or something that's got some weight to it, the balance point is the mean. But the median is where half the area or half the individuals are below the median. So I'm thinking of this is a percent frequency density histogram here, where area is frequency, is percent frequency. So like the mean, if you had this kind of distribution here with 4 guys all together and then an outlier, the mean would be over here, the balance point, but the median would be, well, there's you want to find where there'd be this guy sort of here because 2 guys are below him and 2 are above him. So what happens if a distribution is not symmetrical? So if you get something like that, what you've done is you've just added a small number of individuals at the very high x values. And so you've made the distribution stretch off to the right. It goes far to the right because the individuals have far out x values, but it's short because there's not very many of them. And so what that does is it sort of leaves the median alone. But it increases the mean. So the distribution is said to be skewed to the right if the mean is greater than the median. In a sample, that's the sample mean. So either the sample mean or the population mean, depending what you're talking about. So that's skewed to the right. And I think of it like it's a little mouse with his tail points out to the right. And so whichever way his tail is pointing, that's the way it's skewed. And then skewed left goes the other way. The mean's less than the median, that's skewed left. Okay.